And asking for a minimum or a maximum height. Okay, don't forget that the height part is probably the Y value in your min-max, and you guys know how to do that. The time would be your X value. Ask for when an object hits the ground. Okay, so that's when your Y is equal to 0. Typically, that's your ground, and so you're looking for an X-intercept. So we'll make sure that we know how to do that. It gives you a specific Y, and it wants you to find a specific X. So that's where you put your Y into Y2, and then find out where the two graphs intersect. Okay. Sometimes they'll ask you for a specific X value, so you're just using your second trace value. Okay, we did a lot of that yesterday. And then, okay, this one here, remember that your domain and range are restricted in like a real world context, right? We can't have negative time, and we're not going to have like negative underground kind of stuff.
So we get all the grade 12 from N to Z, looking for picture retake down to the cafeteria. Thank you.
All right. So, oh, I have a plug back there. Awesome. Okay. So just make sure that you can't have negative time, negative length, and if there's a maximum, like that's where your domain or your range, okay, has to hit. It can't be way above. You're just heading out. Mm-hmm. Okay. I better see your photo that has a green shirt on. I'll look for you in the yearbook. Yeah. Nope. He at least has like a legitimate like last name that's been called, even though we all know that it's not really happening. All right. So here you go. Growth of a tree, okay, can be modeled by the function. So guys, this is what we need to be able to understand, right? When we change the variables from X and Y, we just need to, like, we need to be okay with that. And we need to be able to talk about things with X and Y, but then use the variables that they give. Okay, so in this type of equation, this is called function notation. You probably did that a bit more last year. Okay, which one would, okay, we have an H and we have a T. Is the H going to be our X or is the H going to be our Y? What do you think? T is what? Yes. Okay. T is going to be our X because, guys, look, the T shows up here in our equation, just like when we have Y equals, and then we have like, this looks like a linear equation, right? It's a degree 1. So this would be, like, we need to be able to look at this and say, okay, it's a linear equation, degree 1. T is the same as my X value, so that means H is going to be my Y. Okay? Because they're going to talk about H in terms of height, and you just need to be able to make sure that when you're, because your calculator is not going to give you H and T, right? It's going to give you X and Y. Okay, so what happens if they give you a equation, they don't give you a table of values, and they want to know to the nearest tenth of a year approximately how long will it take the tree to grow 32 meters tall? Yeah, what would you do? Yep. Yep. And then what?
And then 32 years. I can, okay, H equals Y. So you put the 32 for your X value?
Okay, so the 32 is meters tall.
Yes.
We said time was X. Yeah, so that's why we need to define these so we know which one to put. Are we finding Y or are we finding X? So here's one strategy. Okay, yeah, you can put this into your, you'd use your X function, minus 0.45. Okay, and then the second thing you would do is you would say Y2 is equal to 32, and then you would find out where they intersect. Did anybody think about using substitution? Okay, you could do substitution. You can say, all right, I know that my height is 32, so if I put, so my second option, okay, for those of you who want to, okay, can be sub the h of t is equal to 32. So you'd have this, 32 is equal to 2.3. I'm going to say x minus 0.4, right? Add 0.45, add 0.45, 32.45 is equal to 2. Like you could do it this way. Okay, so you guys have two choices for this. Okay, x is equal to whatever. Yeah. So you can do it graphically, putting it in your graphing calculator and finding the intersection, or you could do substitution. Okay. So 32.45 divided by 2.3. Okay, gives me 14.1. Okay. So two methods. Now, what was the original height of the tree? Okay. Guys, when the original height of the tree, at what time does that happen? 0. Okay. So if I say time is equal to 0, okay, and I go back to my function, okay, would it make sense just like, should we substitute? Okay, or you could also do it on your calculator. You could say x equals 0 and get it, or you could do the substitution. Okay, so at this point, the original height on the tree, if you already have this, so if we're doing calculator method, we're doing x is equal to 0, and then y is equal to, when we do it on our calculator, y gives us a negative value. Okay, because what's happening here? Original height of the tree. How could we have a negative height of a tree? Say louder. Yeah. Did someone like maybe dig a hole and plant a seed? Okay, so that's how we can interpret the data, is that someone dug a hole, planted a seed, and it took a while for this tree to grow up out of the hole, okay, and to become a positive height. Okay, if you did the substitution method, okay, so I'll kind of keep, the red will be like doing the algebra part. Okay, we said t is equal to 0, so h at 0 is equal to 2.3 times 0. We're just substituting in. Okay, so you could do either way. If some of you are like liking the substitution, kind of nostalgic, brings you back to last year, okay, you can do that, or you can keep with the calculator method. Okay, determine the height of the tree in 23 years. Okay, go. Okay. Probably 1 decimal place. All right, so the height of our tree, okay, if you're getting, what did I get, 52.45? Yep. Okay, you can do 2 decimal places or 1. Okay, I might do 2 because there's 2 decimal places in the original equation. I just looked at it now. Okay, so okay guys, if this was a multiple choice or a numeric response, absolutely use your calculator. If you found this in the written response, you would need to, it'll probably say algebraically determine, then you would just need to show this, the substitution. Okay, so you need to be aware of both methods. Okay, which one you choose just depends on the question that they ask. Okay, but for all of these, yes, you need a sentence answer, so I will try to be a better model with putting in our sentence answers. So the tree will be, okay, 52.45 meters in 23 years. So make sure you include units, full sentence answer to get full marks. All right, our next question is a domain and range question. So some of these, like you have this equation and then you have, like, you can graph it and take a look at it. Okay, in science class, they're investigating trajectories by launching balls with a catapult. Okay, a little bit of physics going on there. The pathway of one particular ball can be modeled by this quadratic function. Guys, what's the leading coefficient, positive or negative? Okay, what does that mean on the right? Down on the right. Okay, so does it make sense that if we were just to kind of like sketch this up on the side, okay, our 0.5, that's our y-intercept. So it looks like we're starting here, probably the height of the catapult. And this ball is doing a down on the right, okay, until it hits the ground. Where h is the height of the ball above the ground in meters, t is the time elapsed. Which of the following, A, B, C, or D, would be a good domain and range? Okay, in order to determine that, we really need to see a few things. We need to, that we talked about this yesterday, so maybe put it in the margin if you don't see it. For domain, you guys need to see your x-intercept. For your range, you need to see your min or your max, depending on what kind of things, like what kind of equation we have. Because we're talking about a downward facing parabola, we have a maximum. So you need to like actually put the equation into your calculator. Let's go ahead and do that together. Make sure you're good with that. So y equals, clear what you have. Guys, get out your calculator. I want to see your graphs. Okay, negative 4.9. Remember, we're substituting x in for our t, so x squared plus 7x plus 0.5. Okay, we're probably going to have to adjust our windows because we're dealing with a really short period of time, right? The catapult takes off and it's probably going to land within a few seconds. So our window, okay, I'm just going to zoom 6 to reset mine. And then I'm going to change my window to, it doesn't make sense to have any negative numbers in the x because that would be a negative time. So we for sure would need to go from 0, and I'm thinking maybe 5 seconds. So I can see if that's too short when I take a look at it. Y, again, once it hits the ground, that's your 0. And then how high is it going to go? I'm not really sure. 4? Maybe. All right, let's try. Okay. Oh, there we go. Okay, so we have a little bit on top that we can see, and 5 seconds is way too generous, right? It looks like it landed after what? 1.5 seconds. So make sure that we can do our second trace, right? We can get our maximum value. Oh, I did it wrong. Give me a sec. It's going to not like me for that. Okay, second trace. Let's do max again. 4. Okay. Left bound, right bound, and then there it is. So our maximum is 0.71 at y equals 3. So if we write that down, okay, determine the height. Okay, we have our max 0.71 comma 3. Okay, and what was our x-intercept? Okay, we can go, if we do second trace, if we do what's called a 0, that's when y is equal to 0. Can we just wait till this is done? Okay. Oh, whoops, I hit the wrong one. Give me a sec. second trace. I want, oh, I hit value, that's why here, 0. Okay. There we go. Our 0 is located at 1.49 and 0. So our x-intercept, 1.49 and 0. Yeah.
If anyone needs their photo taken, please come back to the cafeteria now. We do need everyone to get their photo taken for the yearbook, so if you haven't had your photo taken at all this year, please come down for that photo. Thanks so much. Have a good day.
Okay, so for the max, we talked about we need the max value, so we're going to round that to 0.07. So right away, we can say, well, those ones, sorry, I did that the wrong way, didn't I? That was my height. There we go. Here we go. My height, I have to get to. There we go. I'm looking for my height. So okay. So can you see how quickly, like I just mixed up the X, like the H and the T. Okay. So you just have to be clear in your head which one is which. So we know that this is X and Y, and so this my time and my height. Okay. So your height tracks with your Y value, and your time tracks with your X value. Okay, so in terms of the time, that's where this one comes into play, the 1.5. Okay, so that way I can say, okay, well, my time went more than 0.7, my time went to 1.5. So if you pick C, okay, then you're understanding how to read your graph. Okay, the total time it took was 1.5 seconds before the ball from the catapult hit the ground. Determine the height the moment the ball was released. Okay, this is your y-intercept. You can do that with your calculator. You can also look at the equation and pull off your y-intercept from your equation. Okay, whoops. Okay, y is equal to 0.5. Okay, so the moment the ball was released, okay, it was, so we 0.5 meters. So again, this is the height of the catapult. If they ask you to like make sense of it, you guys are giggly. I just. I will if it gets out of control. Okay, determine the max height of the ball. Oh, no. Like, we you know what? We can have a conversation after about this. Absolutely. Yeah. Okay, determine the max height of the ball. We did the max over there. The max height of the ball is 3 meters. Okay, determine the time the ball reached the maximum. Okay, the time was 0.7 seconds to reach the max height. Woo. Okay, determine the time the ball hit the ground. That was our x-intercept. We've already done all the work. Okay, so the ball hit the ground. Wow, the ball, here we go, hit the ground at 1.5 seconds. Determine the height of the ball at 0.5 seconds. Okay, so with your calculator, okay, you can do trace 0.5. At 0.5 seconds, the height of the ball is 2.8. Yep. I'm going to say, generally speaking, this unit tends to go well. Okay, so if you're like, if this is making sense, okay, I'm hoping that you'll see some much desired improvement, okay, over your marks for this particular unit. So don't lose sight of that. the height of the ball at 0.5 seconds is 2.8 meters. Okay, determine the second time the ball reaches a height of 1.2 meters. Okay, so this question was asked before, kind of like, so this is going to be one of these questions here, where when we draw it, we're going to notice that when we do 1.2 meters, we're going to have two, okay, intersections. So we have to make a y equals 2 first, and it wanted 1.2 meters. So y2 equals 1.2, and then when we graph it, you can see that lovely intersection. And this time it doesn't want the times plural, okay? It's looking specifically for the second time. So so this is y2 equals 1.2, and when you find out what your x value is, you want to make it focus on the second time that there's an intersection. So second trace, intersect, okay? Oh, I'm way over. Come on. There we go. Okay, so to the left, there's the second curve and my guess. Okay, so I get 1.32. So let's say 1.3. Okay, so the second time the ball reaches a height of 1.2 meters is at 1.3 seconds. Okay, and determine the time the ball was above a height of 0.75. Okay, this one I don't think we've seen before, and again, you just need to make sure that you know how to do this one. So what it wants is, it wants us to do the same thing as this one, but now it wants to determine the time that the ball was above a certain height. So you need the starting time, and you need the end time, and then you need to subtract the two to find out the duration. Okay, so this, determine the time, okay, this is actually meaning the duration of time. So you would take your second time and you would subtract the first time in order to get the duration of it. Okay, so let's see what that looks like. So we would go back to the calculator and we would change that 1.2 and we would change that to a 0.75. So let's clear that out, 0.75. Okay, graph. Okay, so it's down here. I'm just going to change my window a little bit. I'm going to change it to 3. There, a little bit easier to see. So I'm looking for, okay, I need to find the time here and the time here, and then just subtract them to get the total time that it's above the height of 0.75. Does that make sense? Okay, we're all like getting it. We are that. All right, so second trace, we're going to do intersect. Okay, first curve, second curve. Okay, so we have our second time was 1.4. So 1.4. Okay, second trace, intersect. Okay. Now you just kind of got to nudge it over so it finds the first intersection. Okay, first, second, and then make sure that it zones in there, which is 0.04. Or I guess, is it 0.04? 0.04, yeah. Okay, so maybe we should have put like one more decimal place in the other one. Okay, second trace. I'm just going to fix that up a little bit. Oh, okay, that one. Second one. I want the other. Okay. I just thought I'd take one more decimal place, 1.39, just because the other one had, okay, there we go. And so our total time, okay. Okay, so the ball was above the height of 0.75 meters for 1.35 seconds. Yes. Just have to do the next example, okay? All right, so I have a question for you because I saw a question on one of your assignments that's coming up. Okay, we'll talk about that after. Okay, so one of the questions, right, gives you some data, but it doesn't tell you what kind of regression the data represents, and it tells you that you need to make a choice, okay, and like decide what kind of regression it is. Maybe I should find a question like that so we can do a real one. Okay, while I'm looking for it, go ahead and grab your workbooks, and we have 2 questions from yesterday, and we have a couple questions from today. Yes, okay, and Jadalyn, you can go. All right, one more pause for those of you who want to, you probably finished the last page of your notes if you wanted to double check up front. Okay, because this one was a cubic. Okay, we can tell because the exponent, this one's for you, Reese. Exponent is 3, so what degree is it? And what kind of function is it? What do we call it? Like, what's the shape? Yeah, that one. What do you call that? You just said it like a second ago. Okay, not linear, not quadratic. That's the one, cubic. Yeah. Okay, so this is a cubic. Okay, and degree 3. Okay, I've already put it in my calculator. Okay, at the y equals, I just put the equation right in. I chose some windows. Okay, so you can see the data just kind of like takes this little woo. So we're kind of like zoomed in on the point of inflection or whatever. Okay, it is the cow horns, exactly. Okay, so then, okay, which of the following characteristics of the weight function should be analyzed to determine the weight of the rat when the study began? So when the study began is time equals 0. So what are you looking for? Are you looking for the x-intercept, the y-intercept, the domain, or the range? Okay, if you guys chose the y-intercept, then you're doing good. So when the study began, x was equal to 0. And then just the last one, after 7 weeks, the researcher's rat is expected to weigh a certain amount. So if we look, okay, our x is the time, okay, and y is the weight. So we're looking for when x is equal to 7, what is y equal to? Okay, so we can do, head back over, and we can just do trace, and we can tell that we're interested in when x is equal to 7. Then y is equal to 470.11. And it wants it to the nearest gram, so just make sure you're cool with rounding, and you guys are all set.